A locating block has no motor, sensor, or moving joint, yet it can decide exactly where a workpiece or tool element stops. Once its contact face wears, chips, shifts, or seats unevenly, the fixture begins repeating the wrong position. The value of the block is therefore not its mass. It is the reference geometry carried by a few controlled surfaces. The shapes shown here are one custom solution, not a universal positioning block form. Grooves may receive mating features, steps may establish height, holes may secure or index the block, and relieved areas may provide clearance. Another fixture may need a completely different outline while performing the same engineering task, reproducing the intended datum every cycle. Repeated loading places sliding, impact, and compressive contact on the datum faces. The specified 3 Y-TZP material exceeds 12.5 gigapascals in Vickers hardness, while an independent reference grade is about 1350. That hardness helps slow abrasive change on contact surfaces, although actual wear still depends on counterface material, contamination, contact pressure, and motion. Custom blocks often contain shoulders, thin sections, holes, and internal corners where local stress can rise. Yttrium-stabilized zirconia uses transformation toughening to shield a growing crack tip. Representative values for this material family are above 1200 megapascals in flexural strength and around 10 megapascal root meters in fracture toughness. Those values do not remove the need for generous RD, supported mounting, and controlled tightening. A locating surface also needs enough stiffness to resist elastic movement under fixture force. The zirconia range used for this type of block is around 200 to 210 gigapascals in elastic modulus. High stiffness helps preserve the relationship among faces, but the final deflection is controlled by block thickness, unsupported span, mounting flatness, load direction, and the position of holes and grooves. For a rigid prismatic part, the familiar 3-to-1 method distributes 6 locating contacts across 3 mutually related datum directions. 3 contacts establish the primary plane, 2 establish the secondary plane, and 1 completes the tertiary direction. Locator placement affects sensitivity as much as locator material. Contact points positioned farther apart create a longer reference baseline and reduce the angular effect of small local errors. Closely grouped contacts can magnify the influence of wear, debris, or manufacturing variation. The useful surfaces should also be accessible for cleaning, with reliefs or channels placed where chips, lubricant, or process residue could prevent full seating. Location and clamping are different functions. Locators establish position. Clamps keep the workpiece against those locators during the operating cycle. The force should travel into supported faces rather than bend an unsupported ceramic span. Redundant contacts must also be avoided, because 2 surfaces trying to control the same motion can create rocking, incomplete seating, or concentrated stress when real dimensions vary. There is no single standard overall size for a zirconia locating block. The component may be compact and stepped, long and rail-like, slotted, grooved, flanged, or nearly rectangular. Its envelope follows the workpiece datum, available fixture space, support spacing, process clearance, and the direction of the operating load. The image therefore represents one design family, not the definition of the category. A useful drawing should identify the functional datum faces before assigning every remaining dimension. It should then define step heights, groove and slot widths, hole position, mounting interfaces, clearance zones, RD, chamfers, and the tolerance relationships among contacting surfaces. Flatness, parallelism, and positional requirements should be applied only where the fixture function needs them, because unnecessary precision adds cost without improving location. In a progressive stamping or forming fixture, a locating block can establish a positive stop or external datum before the die closes. The block does not create the part geometry by itself. It places the workpiece, carrier, or tooling element into the intended relationship, so the next operation begins from a repeatable reference. Each loading and closing cycle brings repeated contact to the same reference faces. If those faces gradually lose height or edge definition, the fixture can repeat consistently and still repeat the wrong position. A hard zirconia datum is used to slow that geometric change, while cleanliness and mating surface condition remain part of the positioning system. During forming, force should close the workpiece against supported locating surfaces instead of levering across a thin ceramic feature. Geometry, mounting, and clamp direction determine whether the material properties are used effectively. Precisely, the block earns its place by preserving a datum, not by resembling any one standard shape.